Good evening, everybody. My name is Cesar Sanchez from Harmony Science Academy in the class of AP Chemistry. Today, we will be conducting a simulation of Beer's Law. Beer's Law is used to determine the concentration of a sample by measuring its absorbance with a spectrophotometer. The premise of this simulation is having different samples of stock blue, number one, and distilled H2O. In each sample, we will be measuring the absorbance and the concentration uh, of each sample. So first, we will fill every sample with different amount of stock blue. For example, the first one is 10 milliliters, second one is 8, third one is 6, fourth one is 4, fifth one is 2, and last one is none. Okay, there we go. Right. Okay. So now that we have every single sample filled up, we will grab this and we will fill up for the first time with distilled water. Now that we have the cuvette with distilled water, we will place it in the machine. Now, when we click 0, it'll give us 100%. Okay. Now we throw it away and then we clean it off. Okay, now that we have it cleaned, we can begin with the other samples. Here goes the 10 milliliter. This time we click measure. Boom, 49%. Now if you notice down here, we get a graph with a linear function already on it. Each dot that we get from each sample will be placed on the graph, which will showcase whether Beer's law is correct or not, on whether it's a linear line on each sample. This side over here, we have a table and the results. So for example, the 10 milliliter has 49% showcased right here, and it has an absorbance of 0.3098. Now, let me get rid of this. Clean. And now we get the 8 milliliter one. Put in the machine. Click measure. Boom. 58%. Now, if you see down here, again, we get our little dot and we get our little results. The results now show the measured is 58 and the absorbance is 0.2363. Now we continue. Clean it off. Now we continue with the next sample of 6 milliliters. Put in the machine. Measure 65.1%. Again, this dot seems to be a little bit more accurate with the line on the graph. It doesn't need to be exact, it just needs to be close. Again, the table measured 65.1, absorbent 0.1864. Now we continue cleaning. Then we do the 4. Put in the machine. This side. Measure 77%. Again, a little dot on the line graph. And we get our table. It shows 0.1135 for its absorbance, and its measured is 77%. Now, we continue. Again, we clean it off. Oh, and then we continue with the 2 milliliters of stock blue. Put it in the machine. Measured 87%. Now, if you notice, there's a pattern. The less amount of absorbance there is, the less amount of concentration there is as well. If you see on the table, 2.310, 0.39, 0.3098, and it keeps going down to 0.462 and 0.0605. Okay, we continue now. Once more, we'll clean off. And if we get pure distilled water into the machine, we click measure. If you notice here in the graph, it is on 0, 0, meaning there is no concentration and there's no absorbance. In the table, it says the same thing. There's 0 concentration, 100%, and 0 absorbance. Both the table and the graph seem to match out. Okay. Now, instead of stock blue and distilled water, we will do this unknown drink. Put in the machine. When we click measure, boom, 39%. This shows over here in the graph, it has most concentration and most absorbance out of any of the other samples that we used. And it also showcases here in the table. Concentration of 3.011 and an absorbance of 0.4089. The graph showing that it is a linear function means that the Beer's law seems to come out correct. Thank you. That is all.